and this video is an analysis of an object falling slower than a rock. The purpose of this lab was to analyze an object falling on tracker and take into account the drag force and the force of gravity. A lunabar with a mass of 0.198 kilograms was recorded falling from a height of 1.29 meters. The length of the lunabar was added by adding a calibration stick, providing a frame of reference to the surrounding objects. An axis was then added, centered on the bar. Since the video could not be rotated, the axis was rotated so the bar moved in the negative y direction. Frame by frame, the bar's position was calculated in Tracker by finding the center of mass in each frame. Using this data, a model was coded in Python to graph and predict the bar's position versus time. Time traveled 0.583 seconds and its mass of 0.198 kilograms. With this information plugged into the initial conditions of the Python code, the bar's model positions were calculated and stored in a CSV file. The positions were calculated using Newton's second law, or the momentum principle, which states that v final equals v initial plus the acceleration times delta t. This is where the mass was inserted, and this is Newton's second law. The code took into account the force of gravity, which equals mass times 9.8 meters per second squared. Right here. The code also took into account the drag force by saying that Fd equals some constant negative b times the velocity. The net force equals both of them combined. Once the drag force equals the force of gravity, the ball would be falling at terminal velocity. The code also graphed the arrows that represented the drag force and the force of gravity. My Python's been running a little strangely lately, but it's supposed to show that the yellow arrow, which is the force of gravity, is so massive that the drag force, the blue arrow, is almost negligible. Predicting the actual experimental data. Here's the over-prediction and the under-prediction. Most of the experimental data aligns well with the model data. Causes for the under-prediction were most likely due to object distortion. This can be caused by recording the video when the video is not recorded at a perpendicular angle. Causes for over-prediction were most likely due to human error, such as miscalculating the constant b in the drag force equation. Other causes of error could have resulted from the few amount of data points. With more data points, the accuracy of the experiment could increase. Questions. The terminal velocity is the velocity when the drag force equals the force of gravity. The model data could have predicted a terminal velocity eventually over a longer period of time. If the object was initially thrown downwards, the drag force would increase, and the object would approach the terminal velocity quicker, since the force is closer to the force of gravity. In the graph, it is seen that the velocity is increasing over time. You can tell by the constantly changing slope. So if the ball was initially thrown downwards, the initial velocity would already be closer to the terminal velocity.